On the periodic table, elements in this row, or two columns I should say, the alkali metals, alkali earth metals, hydrogen, and helium, these are said to be in the S block. This means that the last electrons in all of these elements live in an S-shaped orbital. The transition metals this is the D block. That means the last electrons in all of these elements live in D orbitals. And these non-transition metals, semi-metals, and non-metals, the last electrons in these elements live in P orbitals. So the block refers to the orbital for which the last electrons are in. Now we know when electrons are distances from the nucleus, they live in energy levels as well, and those are indicated by these numbers here. We know the D block lags behind 1, and we pick back up again here at the P block. So, for example, the last electrons in magnesium are in the third energy level. So, 3 energy levels away from the nucleus, 1, 2, 3. And those electrons live in an S orbital. The last electrons in the bromine atom are out there in the 4th energy level, and they live in a p orbital. The last electrons in cobalt are in the 3rd energy level, and they live in a d orbital. Okay, so these rows on the periodic table pertain to the energy level where the last electrons are in, and these blocks pertain to the orbitals that those last electrons are in. Now, if we take aluminum, for example, aluminum has electrons in the 1st and 2nd energy level, but its last electrons are in the 3rd energy level. And when we were writing something called the electron configuration for any element, let's say aluminum, the way we did it is we simply counted starting at atomic number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 until we arrived at aluminum. So the very first electrons in aluminum are in the 1st energy level. They're in that s orbital, and there are 2 of them. The next electrons in aluminum are in the 2nd energy level. They're in the s orbital. There's 2 of them. And we have 6 of them in the p orbital. 1, 2, p3, p4, p5, p6. We restate the energy level in the orbital. The next electrons are in the 3rd energy level, 3s, and there's 2 of them. And the very last electron is in the 3rd energy level, and there's 1 of them. Let's go ahead and do some more practice with that. So let's take, for example, something like beryllium. And I asked you to do the electron configuration for beryllium. I'd press pause and try and do it on your own. Okay, so we're going to start at the top. 1, 1st energy level, s orbital, and there's 2 of them. 1s, 2. So we've moved on from there. We're now going to the 2nd energy level, so we restate it. S1, S2. Okay, done with those. We've now moved on to the p orbital in the 2nd energy level, and there is, actually we're done, 2s2. Let's do another one. Let's do bromine. Actually, I'm going to erase this so we can do it clean. Bromine. Why don't you press pause and try it on your own, and then I'll do it for you. Okay, so we got the 1st energy level, s orbital, 1s1, 1s2. Boom. We've moved on to the 2nd energy level in the s orbital, and there's 2 of those. We're now moving on to the 2nd energy level in the p orbital, and we're still not down at bromine, So that's 2p6. We now moved on to the third energy level, s orbital, 1, 2, 3s2. And we are in the third energy level in the p orbital. 3p1, p2, p3, p4, p5, p6. So we're going to go down to the fourth energy level. S orbital. 1, 2. D lags behind. So we got 3, D, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, fully filled. Now we're going to go back up to the fourth energy level, p orbital. 4p, 1, 2, 3, 4, 5. That's bromine. Why don't we try one last one? I think everybody should try, strontium. Press pause, give it a shot, and then I'm going to do it myself. So strontium, one thing I know here is 1, 2, 3, 4, 5. Strontium is going to end with 5s2. So it's going to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2. So the electron configuration tells us the exact location of every electron. For example, the last electrons in strontium, these are called the valence electrons, are in the fifth energy level in the s orbital, and there's 2 of them. And because electrons are on the outside of all atoms, and atoms make up everything, electrons are responsible for bonding and interaction. And if we're going to study how that happens, we need to know where they are